So in the second half of Chapter 6, what we're going to do is we're going to move from 2 dimensions to 3 dimensions. We're going to talk about actual real-life objects. And we're going to mainly explore the measurements of volume and surface area, but we also want to look at what happens when we look inside of these objects. We're going to look in this lesson about what happens when we slice a 3-dimensional object, what kinds of things take place. Before we get into that, though, we probably need a little bit of a review on the different parts of these 3-dimensional objects, kind of what they're called and all that good stuff. So just kind of moving across the top here, in the top row and the bottom row, we have 2 different types of 3D objects. The ones in the top row, those 4 top objects, are called prisms, and then on the far left you have a cylinder. For a cylinder, for all of these, we're basically named after what shape their base is. The base doesn't have to be the bottom. The base is any shape that's, if there's any shape that's not a rectangle, we'll call that the base. So for a cylinder, the shape is a circle. For a rectangular prism, the base is a rectangle. Here you'll notice we've got a triangle. So the base is a triangle here, and this is a triangular prism. On this far one, you've got a bunch of rectangles. We've actually got 6 rectangles, but then for the other shapes, we've got hexagons. So this is a hexagonal prism. Prisms and cylinders are shapes that have 2 bases. And you'll notice I mentioned with the hexagon, the other sides are all rectangles as far as the prisms go. The cylinder is actually also rectangle. If you imagine you have a piece of paper and you roll it up like a pirate's spyglass, and you look through it, when you unroll that cylinder that you've formed, you have a rectangle. So prisms and cylinders have rectangles for the other sides. So you have the bases. We call the other sides the faces. Again, just to show you've got rectangles here, if you look at the triangular prism, you've got a rectangle right here as well. Below the line here, we have what we call pyramids, and then this shape right here is a cone. A cone, you have the base is a circle, and notice on all of these, you've got one base, and from that base we go up to a point right here. So right here we have what we call a rectangular pyramid, and that goes up to a point right here. Here we have a triangular pyramid, and we actually have a special kind. This is a special kind of triangular pyramid where all 4 triangles are equilateral, are the same. This is called a tetrahedron. You saw that in the Wall of Fire videos that you watched before this. So a triangle, you'll notice the base is a triangle, a triangular pyramid. The base is a triangle, but then the faces are also triangles as well. On the far right, oops, grab the wrong thing here. On the far right, you have a pentagonal pyramid. Let me try to highlight the pentagon here. So you've got a pentagon, and then from each vertex of the pentagon, we go straight up to a point at the top, and you can see the triangles that form from going up from that from those vertices. So that's just a little bit about the different 3-dimensional objects. Again, you name them based on what shape their base is, and that's going to be really important later when we talk about volume and surface area. It's also going to be important when we talk about what happens when we slice these things. So when we talk about slicing a 3-dimensional object, just like you slice a loaf of bread, what we're going to look at is what shape is formed when we open up that object. This is called the cross-section. A cross-section is a shape that you form when you cut through something that's 3-dimensional. So in the video, you saw if you slice through this rectangular pyramid here, if you slice parallel to one of those bases, you form a rectangle. Okay? There's a couple different ways you can slice. We're going to focus on parallel and perpendicular, and then we're going to focus on kind of random cuts as well. And when we do this, what we're doing is we're looking at what shape we form. So we've got a couple different parallel cuts here. So we already talked about the rectangular prism. If you cut parallel, notice how the red square is parallel to the yellow faces or the yellow base with a rectangular prism. Any side can be the base, really. So when you cut parallel or perpendicular on a rectangular prism, you form a rectangle. When you cut a cylinder, you'll see it right there. The cross section is a circle. When you cut parallel, again, you have to cut parallel to the base there. So if I draw the circle here, you can see it. Okay, it's a three-dimensional circle. But again, if I slice that cylinder off, you would have a circle sitting there staring at you. With a triangular pyramid, let's see if I can resize this or not. Here we go. If I got parallel to the base is a triangle, so basically this line right here, I want to cut parallel to that. So I'm going to do another line maybe further up the triangle, so I'll cut a line right here. I want to go to parallel to this line too. So I'll do another line right here, and you'll notice as I make this cut, and I'll go a line parallel to this last line here. When I cut a triangular pyramid parallel to the base, I form a triangle. Look what happens when I cut get this down here, okay? Look what happens when I cut the hexagonal prism. So the hexagonal prism, again, if I cut parallel to the base, so here's one side of the base, I'm going to cut this up at this point here. Here's another side of the base, so I'll cut parallel to that side. Here's another side, so I'll cut parallel to that. It's getting a little trickier. I'll cut parallel to this side as well. You'll notice what shape I'm starting to form here. I am forming another hexagon. Move this out of the way, maybe not. I can't quite move it there, but you'll notice I've got another hexagon right there. So when you cut in a prism, when you cut parallel to the base, you form the same shape as the base. Look at what happens. You can see below the same thing happens when we cut pyramids parallel to the base. So here, the base is a rectangle. Notice when we cut this pyramid a little bit of the ways up, I form another rectangle. When I cut this cone a little bit of the way up, once again, another circle is formed parallel to the base. Since I'm cutting parallel to the base, the shape that results is the same shape as the base. Same thing with the triangular pyramid here. When I cut parallel, this line, I just cut a little bit further up at the same angle. That's what parallel means. It's the same slope. So if I cut at the same slope as the slope of the base, I get the same shape as I have down below. Okay, so for parallel cuts, whenever you cut parallel to the base, you form the same shape as the base. Perpendicular cuts are slightly different, and this depends on the shape of the faces. So if I cut, you see the first picture here, if I cut a cylinder perpendicular to the base, if I cut down through it like this, I form a rectangle, okay? And it doesn't matter where in the cylinder I could cut further up like this. Move this over here. I just cut a little bit of a smaller rectangle, okay? That was something that you saw in the Wall of Fire video that you watched. If I cut perpendicular to the triangle's base, okay, so I'm going to cut perpendicular. If this is the baseline, I'm going to cut perpendicular to that. I'm going to try and do this here, okay? And this is the other baseline, okay? I'm going to cut perpendicular to that. Okay, it's kind of hard to see, but I form the same shape as this face here. Okay, the face of a triangular prism is a triangle. I could also cut. I think that's it. I could cut further up or further down, but if you cut perpendicular to the base of a triangular prism, you form a rectangle. Perpendicular to the base here on a hexagonal prism. Okay, so here's the base down here, right? So if I got perpendicular to that, I cut this distance here, and then I'm going to cut across the top, perpendicular to the base again. And notice we form another rectangle. Again, it doesn't matter where I cut. I could cut across the top here. That's perpendicular to the base. And there's the rectangle that forms. I could cut right here. Again, perpendicular to the base. So I cut straight down. There you have it. Okay, that's if I cut at a 90-degree angle. If I cut slightly different angle, I might form something else. That's something we're going to talk about in the next slide. For a cone and for a pyramid, when you cut, there's two different things you could do. You could cut through the vertex, or you could not cut through the vertex. For a cone, I resize this. If you cut through the vertex, you can see we're forming a triangle. If I cut further down through the vertex, again, perpendicular to the base, I just end up forming another triangle. Okay? With a pyramid, it's a little bit different. Okay? With a pyramid, because the sides aren't rounded. So with the pyramid, if I cut through the vertex, again, I form the same shape as the face. Okay? It might not be the same size as the face here in blue. It's a different size than the red triangle that I formed, the cross section that I form. It's a different size, but it is the same shape. It is a triangle. Notice what happens. Let me resize this. Notice what happens if I cut somewhere other than. Again, I'm perpendicular to the base, though. If I cut somewhere other than, imagine that this side, this face, is coming out towards you, right? That means this line is going to be coming down towards you as well, right? To be perpendicular to that base, it's going to run around. Imagine you're kind of sliding down from this point down to the bottom of there. The other side, you're sliding down to the bottom of there, and then you just cut from point to point. We form a trapezoid when you cut through something that is not the base. So you can form a trapezoid if you form, because there are 4 sides to cut into here. Okay? Let's look at some other cuts that we could form. So for a rectangular pyramid, they showed you a couple different ones. For a cube, this one was interesting, I thought. The one that she did where she just kind of cut off the corner like this, you form that, let me change colors. You form that triangle if you just cut off a slice of the corner. She also in the video, the Wall of Fire video, talked about if you could make that beam of light hit all 6 sides of the cube, you would form a hexagon. Now, you would need to have a 6-sided figure in order to make a 6-sided cross-section. So you couldn't do a hexagon if you had, say, a triangular pyramid, okay? Because a triangular pyramid has the base and has the 4 faces. So there's 5 sides of that, okay? You could do a pentagon with that. But you couldn't do a hexagon. 2 that she mentioned for a cylinder, she mentioned the circle you could form, right? If you cut parallel to the base, you form a circle. If you cut perpendicular to the base, you form a rectangle. But that's if you cut parallel and perpendicular. What if you cut at another angle? Well, if you cut at another angle, the shape you form is something called an ellipse. Okay? An ellipse is kind of like a flattened out circle. That's actually the shape that planets orbit around. They don't orbit in perfect circles. Johannes Kepler discovered that. But that's kind of another little sidebar there. We're not going to really do much work with ellipses, but that's another shape you could form if you hold it at different angles. Kind of like with the cube. She held that cube at a different angle to form the triangle and to form the hexagon. If we don't go parallel or perpendicular, there's other things you could do, okay? Like with the tetrahedron, she formed a triangle. She formed a rectangle by hitting 4 of the sides. And if she changed the angle on the rectangle a little bit, she formed that trapezoid or that square, okay? So it's all about the angle at which you hit that could form different shapes. Generally speaking, when we do these types of problems, we're going to be working with parallel and perpendicular cuts, but you need to be aware that you might be asked, okay, what if we cut the shape at an angle other than parallel or perpendicular? What kind of shapes result? So let's talk about how we apply this then. Again, I said we're going to talk about a lot about surface area and volume. So one of the types of problems we'll deal with here is, what if we slice this three-dimensional object? What is the area of the shape that is formed? What is the area of the cross-section? So when you do this, the first thing you need to do is identify what shape the cross-section would be. Because remember, area of a parallelogram or a rectangle is base times height. Area of a triangle is base times height divided by 2. So you need to identify what shape it is so you know what formula to put into action. You remember when we slice things, slice a cylinder perpendicular, resize this a little bit. When I slice a cylinder perpendicular to the base, I form a rectangle. We slice down the sides, right here, okay? And this is assuming you slice along the diameter. I should have specified that. But if I slice this perpendicular, notice I form a rectangle, and you can see what the, let's see if I can grab this. I don't know if I can. I can see what the dimensions of this would be. The bottom would be 10, and the height here would be 15. So the area of this, area equals base times height, right? 10 times 15. So the area of the cross-section is 150 centimeters squared. Okay? Pardon the handwriting there. So that's the area of that cross-section. Okay? If I slice parallel, slicing parallel, I just take this, okay, I slice at the same slope as the base. Let's see if I can separate this now. Okay, so that slices that right there. Okay, so I've got a circle, and you'll notice the diameter of the circle. Can I zoom in? No. Okay, so the diameter of the circle is 10. Area of a circle is pi times radius squared. Well, the radius would be 5. So I need to do 3.14 times 5 squared, exponents before multiplication. So I'm going to do 3.14 times 25, and I get 78.5, again, centimeters squared. Okay, two different cross sections, I get two different areas. Okay, if I slice perpendicular, it's 150 centimeters squared. If I slice parallel, I get 78.5 centimeters squared, because I get two different cross sections here. Okay, down below, what are the areas of the different cross sections I could get of this prism? Okay, and I should say if I slice parallel. Kind of poorly worded questions here. Don't worry, they'll be better worded on their the homework. So the first way I could slice this, I see right away, I could go here, 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 and here, right? So I could form this rectangle. All right. So this rectangle would be 5 by 6, right? So the first area is 5 times 6, or 30 centimeters squared. Okay? So that's the first cut. Come on, let me grab you. Oh, hold on. This is not working the way I want it to. Well, whatever. Let's just erase that, if I can. Nope, I can't. Okay. The other cut I could do, I could cut parallel to the bottom of the rectangular prism. So I could cut this way. Okay, now that would be 11 here and 5 here. So I have an 11 by 5 rectangle for that. So the area of that cross section will be 11 times 5, or 55 centimeters squared. The last way I could cut it, okay, let me erase that. So I cut it up and down, I cut it side to side, The last way I could cut it is like this. Whoops, a little bit not parallel there. So I could cut it across the top. If I do it this way, I've got 11 here and 6 here. So that area is 11 times 6, or 66 centimeters squared. So 3 different cross sections because there's 3 different pairs of bases. There's the front and the back. The front and the back is 11 by 6. The left and the right is 5 by 6. And the top and the bottom is 11 by 5. So since there are 3 different pairs, I have 3 different cross sections here. So there's kind of 2 things we talked about that I want you to get some practice with here. Number 1 is identifying what shape the cross section is. Okay, what shape do we form? And the other thing is, and that's if I do parallel, perpendicular, or maybe a different cut. The other thing, and that's a lot of visualization. The other thing is finding the area of the cross sections you form if you cut parallel or perpendicular, or thinking about what the areas of different cross sections would be. Again, that comes down to identifying shapes as well, though. So let me know if you have questions with the homework. Good luck.